Hello students, in previous lecture we saw the encoder. Now in this lecture we are going to see the decoder. So what is a decoder? So decoder is exactly opposite to a encoder. So encoder is used to convert the general code into a machine code, whereas a decoder is used to convert the machine code into a general code. Okay, so suppose we want to add some information or we have to add the data to a computer. Okay, so we use keyboard. So through keyboard we enter the data to in a computer. So we write the data in human language. We write the data in human language, but human language is not understandable to a computer. So computer knows only machine language, that means binary language. So at the input side we use encoder, which convert human language into a machine language, and then computer operate on that information and give the output, but output is in the form of a machine language. So the machine language is not understandable to a human. So at that stage we use a decoder circuit. So decoder circuit converts machine language into a human language. Okay, so decoder and encoder is exactly opposite to each other. Encoder convert general code into machine code, and decoder convert machine code into a general code. Okay, so decoder is a combinational circuit. So this is the block diagram of a decoder. So decoder has a n input and m 2 raised to n output. Okay, so figure show the block diagram of a decoder. It has n input and 2 raised to n output. Okay, so suppose n, there are 4 inputs. So 2 raised to 4. What is 2 raised to 4? 16. So it produces 16 output. Okay, if n is equal to 2, then it produce 2, that means n is 2, so 2 raised to 2, it produce 4 output. If n is 3, then 2 raised to 3, that means it produce 8 output. Okay, so decoder is identical to demultiplexer. So we know the demultiplexer. So decoder is similar to a demultiplexer. The operation of decoder and demultiplexer is same, but the only difference is that in demultiplexer there is only one input, but in decoder there are multiple input. Okay, so without any data input, it perform operation which are exactly opposite to a encoder. Okay, so decoding is a process in which the information present in one code is obtained back to a desired code. So desired code is nothing but a human language. So for example, the binary output of the digital circuit is converted to a decimal. So we know the decimal language 0, 1, 2, 3. Okay, so binary information is converted into a decimal information. So thus the decoder perform converse operation of encoder. Decoder convert machine code into a more general code. Okay. Now these are the type of decoder: 2 is to 4 line decoder, 4 is to 16 line decoder, then 3 is to 8 line decoder, BCD to decimal decoder, BCD to 7 segment decoder. So these are the type of decoder. So we will see this type one by one. So first is 2 is to 4 line decoder. 2 is to 4 line decoder. That means 2 input, 4 output. 2 input, 4 output. So there are 2 input A and B and 4 output D0, D1, D2, D3. So 2 is to 4 decoder. So there are 2 input A and B. So input A and B and 4 output D0, D1, D2, D3. So this is the truth table. So when both the input are 0, 0, then D0 output is connected, selected. When A is 0 and B is 1, then D1 output is selected. When A is 1 and B is 0, then D2 output is selected. When A is 1 and B is 1, both are 1, then D3 output is selected. Now, this is the Boolean expression for all the 4 outputs. So, for D0 output is 1 when both the inputs are 0, 0. That is A bar, B bar. So, D0 is equal to A bar, B bar. Now, D1 is 1 when A is 0, B is 1. That means A bar, B. A bar, B. Now D2 is 1 when A is 1 and B is 0. That means A, B bar. A, B bar. So for 0 we write bar. and D3 is 1 when A and B both are 1 1, that means AB. So by using this Boolean equation we draw the logical diagram. There are two input A and B. This is A bar because here in we connect NOT gate, and this is B and this is B bar because NOT gate is connected. A bar, B bar. Now this is the output. So for D0 there are ANDing operation A bar B bar. So in between A bar and B bar there is ANDing operation. So here we use the AND gate. So the equation for D0 output is A bar B bar. So the input of this AND gate is A bar B bar. Okay. Then for D1 the equation is A bar B bar. So the input of this AND gate is A bar B. Okay. For D2 the equation is A B bar. A B bar. So these are the input of this AND gate. Now for D3 the equation is AB. So the input of this AND gate is A and B. So in this way we design a 2S24 decoder. Okay. Now the next type is 3 to 8 line decoder. So what is 3 to 8 line decoder? So 3 to 8 line decoder means there are 3 input A, B, C and 8 output. D0 to D7, 8 output. 3 to 8 line decoder. So here 3 input A, B, C and 8 output. Okay. D0, D1, D2, D3, D4, D5, D6, D7. Okay. Now D0 is 1 when all the inputs are 0, A0, B0, C0, then D0 is 1. Then D1 is 1 when A is 0, B is 0, C is 1. Then D2 is 1 when A is 0, B is 1, C is 0. Then D3 is 1 when A is 0, B1, C1. D4 is 1 when A is 1, B and C are 0. D5 is 1 when A is 1, B is 0, C is 1. Then D6 is 1 when A1, B1 and C is 0. And D7 is 1 when A, B, C both are 1, 1. So by using this truth table, we write the Boolean equation. Okay, so for D0, D0 is 1 when A, B, C all are 0. So for 0 we write bar, that means A bar, B bar, C bar. Next, then for D1 A bar, B bar, C, A bar, B bar, C. Then for D2 A bar, B, C bar, A bar, B, C bar. Okay. Then D3 for D3 A bar, B, C, A bar, B, C. Then for D4 A, A, B bar, C bar, A, B bar, C bar. Then for D5 is 1 when A, B bar, C bar, A, B bar, C. Then for D6, A, B, C bar, A, B, C bar. Then for D7, 1, 1, 1, that means A, B, C. So by using this expression, we draw the logical diagram. So there are three inputs, A, B, C. This is A bar, this is B bar, and this is C bar. So this is the AND operation. So there are 7 in outputs. So for there are 8 outputs, D0 to D7. There are 8 outputs. So for 8 output we draw 8 AND gate. We draw 8 AND gate. Okay. For from D0 to D7. Then by using this expression we draw the logical diagram. So the for D0 the expression is A bar, B bar, C bar. So A bar, B bar, C bar. For D1 A bar, B bar, C, A bar, B bar, C. Then for D2 A bar, B, C, A bar, B, C bar. Okay. So in this way we draw the diagram. Okay, up to D7. Okay, now the next is 4 to 6 line decoder. Same procedure is followed. First we draw the logical block diagram, then truth table. Then by using truth table we write the equations, and by using equations we draw the logical diagram. Now for 4 to 6 line decoder there are 4 inputs. For 4 input, there are 16 output from Y0 to Y15. Y0 to Y15, there are 16 output and only 4 input. So this is the block diagram D, C, B, A. Okay. So Y0 is 1 when D0, C0, B0, A0. Y1 is 1 when D0, C0, P0 is 1. So similarly, Y15 output is 1 when D1, C1, B1, A1. So by using this truth table, we draw the expression. So expression for Y0 is D bar C bar B bar A bar. Y1 is D bar C bar B bar A. Y2 is D bar C bar B A bar. Y3 is D bar C bar B A. So we can write this equation by using this truth table that we saw in 2:4 and 3:8 line decoder, which is similar to a the 4:6 line decoder is just similar to a these two decoder. Okay, also only difference is there are 4 input and 16 output, but the procedure is same. So we write first, we write the truth table, then by using truth table we write the boolean expression, and this is the logical diagram. So for y0, the expression is d bar c bar b bar a bar. Why d bar c bar b bar a bar? Because for y0 is 1 when t c b a both all are 0. So for 0 we use bar, that means d bar c bar b bar a bar. Yes, d bar c bar b bar a bar. So here d bar c bar b bar a bar for y0. Then y1. So what is the condition of y1? D bar c bar b bar a. Here d bar c bar b bar a. So here d bar c bar b bar and a. Then for y2, the condition for y2 is 1, then d bar c bar b a bar, d bar c bar b a bar. So d bar c bar b a bar. So in this way we draw the AND gate for up to y15 output. Okay. So by using this truth table, we can write this expression, and by using this expression, we write this logical diagram. Okay. Now the next type is BCD to decimal decoder. Next type is BCD to decimal decoder. So BCD, we know the BCD numbers. So BCD numbers are from 0 to 9. BCD numbers from 0 to 9. So for DCB, there are 4 input and only 10 output. So BCD number from 0 to 9. So for 0 to 9, there are 10 numbers. So for y0, y1, y2, y3, y4, y5, y6, y7, y8, y9, and only 4 input. This is BCD input and this is decimal output, because BCD to decimal decoder. So we give the binary code here, and depending upon that binary code, the particular number is, we get a particular decimal number. So 0000. So for 00, y0 is 1. 0001, y1 is 1. 0010, y2 is 1. 0011, y3 is 1. And for y4, 0100. Y5, the condition is 0101. Y6, the condition is 0110. Y7, the condition is 0111. And y8, the condition is 1000, and y9, the condition is 1001. Okay, so this is the truth table. So by using this truth table, we draw this, we write this boolean expression. So for y0, the condition is d bar c bar b bar a bar, d bar c bar b bar a bar. For y1, the condition is d bar c bar b bar a, d bar c bar b bar a. Then for y2 is 1 when d bar c bar b a bar, d bar c bar b a bar. Then for y3 is 1 when d bar c bar b a, d bar c bar b a. Then for y4 is 1, y4 is 1 when d bar c b bar a, d bar c b bar a. Then next is y5. So for y5, the condition is d bar c b bar a, d bar c b bar a. Then for y6, y y6 is 1 when D bar C B A bar, D bar C B A bar. Then for Y7, the condition of Y7 is D bar C B A, Y7, D bar C B A. Then for Y8, condition is D C bar B bar A bar, D C bar B bar A bar. And then for Y9, the condition is D C bar B bar A, D C bar B bar A. Now by using this expression, we draw the logical diagram. There are 4 input D C B A, and this is D bar C bar B bar A bar. So for Y0, the expression is D bar C bar B bar A. So D bar C bar B bar A. For Y1, D bar C bar B bar A. D bar C bar B bar. Then for Y2, D bar C bar B A, D bar C bar D A bar. For Y3, D bar C bar B A, D bar C bar B A. So in this way we can draw the logical diagram by using this Boolean expression. Okay. Now the next and last type is 7 segment display. So this 7 segment display we will see in our next lecture. Okay. Now we will stop here.